Okay, so to address some of the physics issues, now this is not my project, and so I don't have a real clear sense of how this project was running, what the exact issue is. But when I hit the play button and after kind of playing around inside the scene and I'm just kind of clicking on the things that I assume are rigid bodies or objects that should be talking to the physics engine, and objects that are interacting as colliders, I'm noticing a couple of things. So I'm going to start with the spheres. And what I'm doing really quickly here is I'm just selecting a sphere and I'm just checking out the rigid body component and getting a sense of what's going on over here. Now, Paul mentioned that things were running really slow. And so the first thing I'm looking for is anything obvious that would jump out. And setting the drag up higher would cause things to slow down. And that didn't seem to be the case for most of the objects that I selected, okay, when it came to the spheres. The spheres were mostly, they appear all to be kind of set to the same, except for there's a sphere that's sitting on top of this pillar down here at the bottom. And I noticed its mass is set to this kind of funny value. Now this Unity came up with this calculation. Maybe it's kind of a placeholder, or maybe this field was selected and the student was trying to change something else in the environment, and this is basically just kind of missing some data. And so I'm just going to add a value back into it. Now, I'm not sure that that alone would cause a problem, but kind of cleaning up some of these things, if there was something hiding in there, that could be one way to kind of streamline some issues. And as I notice these cubes are falling too when I hit the play button. I see a couple cubes are falling. I saw this thing move and this cube back here. And so I'm scanning around and I'm taking a look at the cubes, and one of them jumped out. Now there's a difference between the mass here, and that's not a big deal. The physics engine should be able to calculate this stuff. But when I selected on this cube, I noticed that this mass is 0.0002, and that's okay that we make something just a fraction of a unit. However, I believe, and I'll have to do a little bit of research on this, but I think we can only go about 5 or 6 points out in a floating point number. So anytime you have a 0.00 or a decimal point here, we're talking about floats. And floats are a little less efficient than integers, but I'm going to suggest that we stick to, unless we have a compelling reason and we're letting Unity calculate things, I'm going to suggest that we stick to no more than the thousandths or 3 decimal places over. So I'm just kind of removing a 0 from the equation just to kind of see if that helps smooth the math out. It doesn't have to calculate down to a really small fraction. In fact, as we kind of move things around, if we use this slide value or kind of tinker with things in space, we'll notice that transform components use these floating point numbers as well. And in most cases, numbers will be rounded to the thousandth decimal position here. So decimal point followed by 3 integers. Now, of course, we can calculate lower than that, but we'll assume that there's some efficiency being accounted for there for a 3-point decimal place. So I'm going to make that adjustment. And now those things in itself should not be a major issue. And when I hit the play button, I don't, I'm seeing some slightly different results going on. I've noticed that this is more of a dramatic catapult action going on here, but I'll assume that's just because we increased the mass of this rigid body just